So we'll talk about flow charting, and flow charting has a long history to it. So definition of a flow chart. A flow chart is a collection, a diagram basically. I mean, you could read this, I'm not going to read it to you, but it's basically a diagram that we're going to use to show the flow of the steps of a program. So kind of a step-by-step of decisions we're going to make along the way, and then maybe what task we'll perform if a certain scenario occurs. So you can think of it as something like when you go to log into Facebook, they probably have a thing where they'll check the username and password you've entered to see if it matches the one that's in their database. And if it does, it'll let you log in, and if it doesn't, the flow will go to somewhere else. It'll go to a page that says your password is wrong, try again. So we're going to try to model a design like that, so we get it as a picture. We could follow the flow of the thinking that goes on. So here's a flow chart for, this is a flow chart for repairing a lamp. So it's not necessarily tied to computer programs, flow chart. So the flow chart here says that we're going to repair a lamp. We're going to use this. I'll go over what these different shapes mean. A diamond usually means there's a question that has a yes or no answer to it. So we have a lamp that's broken, so what we're going to do is we're going to say, is the lamp plugged in? And it could either be an answer of yes or an answer of no. If the lamp is not plugged in, then our actions, so these kind of rectangular boxes, is where we perform steps. So we plug the lamp in, and hopefully that will fix the lamp. If the lamp is plugged in, then to us, because we understand lamps and how to figure out what's wrong with the lamp, we then go to the next question. Is the bulb burnt out? And if the bulb is burnt out, then we would replace the bulb. And then otherwise, if the bulb is not burned out, then it's plugged in and the lamp is working fine, then our next task is to repair the lamp. So this is kind of just a simple idea of the flow of how you would diagnose what's wrong with a lamp. Okay, so we're going to have a certain set of symbols that we're going to use. So I'll just go through all the symbols that are used in a flow chart. So the start symbol is usually represented with circles or ovals. That's the area where we start from. Arrows are going to be where we connect from one of our shapes to another shape. It's the flow. You go in the direction of the arrow. So the arrow would always have some direction to it. And like we had with the example before, the decision box would be, whether the arrows could be labeled like yes or no, like an example I just did before. Rectangular shapes usually identify where we're going to perform some kind of a task. So like in the last example, we said that we'll insert a new light bulb or whatever the task was. So the tasks that we perform are going to be written in those rectangular boxes. Subroutines, which we'll get into a little bit later on when we start talking about programming basics, subroutines are going to be in rectangles with double-struck vertical edges. So the only difference between a subroutine and a task is a subroutine is something that different parts of your program could call it, keeps performing the same task over and over. Our program is always going to ask for some input from a user. It's going to perform some type of computation and then print out. Kind of like the example we went over last class. We asked them to pick a choice, 1, 2, 3, or 4. They hit a button and then we told them whether they were right or wrong. So they're giving us input and we're giving them output. So the input and the output would go in these parallelograms. So that's where two lines are parallel and then the sides are not necessarily like a rectangle but on an angle. So that's where we would do our input and output in those symbols. A couple more symbols. A prepare condition is represented by a hexagon. So that's, I think like, no, stop sign is not hexagon, it's a six-sided symbol. So it shows operations which have no effect on preparing values for subsequent conditions later on. A condition or a decision, we just saw an example of the diamond. So anytime you, and actually the definition is that it's a rhombus. Anybody remember what a rhombus is from high school math? It's a four-sided figure where all four sides are the same plane. So you might think it's a square or a diamond, but it could be kind of squished. So it doesn't necessarily have to be a perfect square, as long as it's a rhombus. And inside those triangles, we could ask a question. You know, is the light bulb burnt out or not? And if yes, take one pad, no, take another pad. Yeah? Did you have a question?
No,
Oh, okay, sorry.
I was just scratching.
Okay.
Sorry.
Okay, so, and yeah, we saw an example like that. And a lot of this is intuitive, and then you don't really want to memorize these shapes, but just realize that different shapes perform different functions in our flow chart. So then generally a junction box would be represented as kind of a black cloud or black blob. And so that could be where different parts of our program could join together. So that's where multiple inputs could come in and multiple outputs could come in to a junction box. Then labeled connectors or identified labels inside the circle. So this is a little bit more advanced. Concurrency control is where like maybe you have a phone app and a website that are reading and writing to the same database, and you only want one reading and writing at a time. So that we could have a symbol for concurrency control. So that ends up being a little transverse line with any number of entries and exit arrows. Okay, so we showed, one simple example, and later on in the course we could come up with other examples. The history of flow charting, it actually came out in like 1921. Mechanical engineers used to use it back then. Then in 1947, computers started being manufactured by IBM. IBM started formalizing these symbols. And then by 1970, the use of these things started going away because programming languages, other than like BASIC, kind of built into the code. You would read the code and tell the flow of it. So it used to be that you would draw these diagrams, and then from these diagrams, a programmer or multiple programmers would follow the way the program runs. And then if you wanted to change how the program ran, you would change the flow chart and start changing the corresponding code with it. So since IBM Corporation formalized it, IBM used to give this to every employee. And remember, I got one of these when I joined IBM a while back. But it's basically all the symbols we just talked about. So you can use this stencil to draw your symbols and draw arrows connecting the symbols together. And so then today, the idea of mapping out your program is use this uniform modeling language, which is really derived from flowcharting, but that's pretty much what's more popular now for modeling your program if you wanted to model it out on paper or on a blackboard or a whiteboard before working on the code. That's pretty much the formal way to do it now. And the reason why we got away from flowcharting is when you flowchart a program, you're following arrows, and chances are you're writing your code to say if something, if a certain thing is true, we perform a certain task. If something is false, we go back to the top, and you end up wanting to do a lot of go-to statements in your code. And there's formal reasons why go-to statements are not good to use in the program. So one side topic is flowcharts do not describe, flowcharts describe the processing of your program. It doesn't describe where the data goes. So there's another type of diagram, I won't get into it here, but it's a data flow diagram. And that shows where the data goes, and that would be, we'd have symbols like I say, I'm not going to go into all their different symbols, but basically, here's a subset of their symbols. So if we wanted to, this is the set of their symbols, and then if we wanted to say that we have a database, and the database is an input into our program, then our program performs some type of computation that sends output to the customer. That was what the data flow would look like. So this is saying the data goes from a database to our program, and then after processing goes out to the system. So the flow chart doesn't describe where the data goes. The flow chart describes the decisions that are made. And then an example of a program in BASIC. So since we're learning BASIC, the basic programming language in our class, and what we did last class was we used the Visual Basic, the Microsoft Visual Basic Studio. So we started building an app on the screen. We were dragging buttons on and areas to read and write text from. And then when we clicked on those individual areas, we had an opportunity to start putting in lines of basic code. But what we were building was one big basic program. So here's an example of just one big basic program that's not written in the Visual Studio. It's just regular basic code. So what does it look like it's doing? Even though we haven't really talked about what the basic language does, what does it look like it's doing? These are actually line numbers. And back in probably the 1960s, the editor would give you the line number of 10, then 20, then 30, then 40, because you might decide that somewhere between 10 and 20 you'd like to insert a line, and they didn't really have good editors back in those days. So you would, at the bottom, you would type in like 15, and then you type in some code and it would know to insert line 15 right there. Now you would just put the cursor there and just insert it. So this concept of line numbers doesn't make sense anymore. But, so the numbers down the side are just line numbers. So this is basically, the basic code is saying input, and then it goes, what is your name? And then it's saying, $$ is a variable to store the person's name in. So the first line of this code will ask the person, what is your name? And then there'll be an expectation that they're going to type in an answer. So the computer will sit there waiting for an answer. And then when an answer comes in, the next thing it will do is it'll say, hello, whatever they said their name was. So if you said your name was Susan, it's going to say, hello, Susan. And then it's going to say input, so it's asking for input, but it can give a message. So it's saying, how many stars do you want? And then you could say, so a variable followed by a $ means it's a collection of characters, like a person's name. But if you don't have the $, then it's assumed you're going to be giving a number. So you could say how many stars do you want, and you'll give an answer, and it'll be written into a variable called n. So now we have, this is now a string, because it has a $, and we say it equals double quote, meaning it's a string of no variable. And now we're going to do a for loop. And don't worry if this doesn't make sense right now, this will make sense as the course goes on. But we're going to say for the variable I equals 1 to n. So we're going to keep repeating something over and over and over while counting I, going from 1, then to 2, then to 3, all the way up to n. So we're going to say the string, we're going to string together all the stars. We're going to say the string equals the string plus an additional star. Now this is a basic programming concept. When you see next I, it assumes this is part of, there's a line that says for I going from one number to another. So the next one will say whatever the value of I is, add 1 to it, and then go back to here again. And then it'll add another star. So it'll keep doing these lines of code over and over and over for n times. So if you ran this program, it would say, what is your name? Let's say you typed in Susan. It would say, hello Susan, how many stars do you want? Suppose you said 7. Then what it'll do is it'll say, it'll set the variable I equal to 1, add a star to the blank string. Then I becomes 2, adds another star. I becomes 3, adds a third star. So it would create a string of 7 stars. Then once it built the string of 7 stars, it then prints out the stars.
How quickly does that process happen, where it's adding the stars, where it's reading
The speed at which,
Yeah,
oh,
it's
that would be
like-
the speed of the processor of the
Okay.
computer you're on, which now processors are like
So it's
3
like
gig.
seamless?
Oh, yeah, it would happen instantly. But probably back in the 60s, it took a while. And it's funny, just seeing like, you know, I got this code snippet off the internet, and I see these numbers, and I'm like, oh, I recognize that, what is that again? And I remember you had to, that was back before they had good editors, so, you know, you had a line 10 and a line 20, and then you realize, oh, I want to put some things between them, and it went 11 through 19, you run out of numbers, you'd have to retype in the code again with new numbers. Okay, so then going forward, so this next I, it's not very clear, but like these 3 lines are kind of grouped together. It's a routine that's going to happen over and over until the value of I, which keeps getting incremented, finally hits the value of n, then it can stop. And then we'll drop through to the next line. So other programming languages make that a lot more clear what's going on. Okay, then I'll ask, do you want to do more stars? And you can answer, I guess you can answer yes or no. So it's basically saying if the length of your answer is 0, that means you didn't really give an answer. Let's go back to this line. So this line saying go to 90, means we're going to go back to line 90, which is here in the last again. And then eventually we're going to take the first character you give as your answer, starting from the left. And if that's either a capital Y or a small y, then we'll assume you somehow answered yes. Yes or yeah or something like that. And if that's the case, then we're going to go to line 30, which is up here, and then we're going to ask how many stars you want. So it's going to be, we'll ask, so basically what this program is doing is it's asking how many stars do you want? Whatever number you say, it'll print out that many stars. Then it'll ask you, would you like to pick another number of stars? And if you keep saying yes and answering stars, it'll keep doing that. If you don't answer with a capital Y or a small y as your first letter, then it'll just print goodbye, whatever your name is, and that'll be the end of the program. So technically, if you answered like yellow, or you want more, you want to answer more stars. If you gave any word that begins with Y, that's considered a yes by this program, and anything else is considered a no. So the output of this program would look something like this. Right. So you'd run it, it asks you, what is your name? You say Mike, it says, hello Mike. How many stars would you want? You say 7. Then that for loop builds 7 stars. It started off with a string that was empty, and then it said the string equals the string plus a star. Then it said the string equals the current string plus another star. Then the string equals the string plus another star. And worked its way through and then printed it out. And then it said, do you want to print more stars? If you say yes, or anything that starts with a Y, it goes back up to the top and asks you how many you want. If you say 3, it'll put down 3 stars. Let's say you want more stars. If you said anything that doesn't start with a Y, it'll say goodbye. And that's the way that program works. So if you wanted to, this might be a simple enough program, but you might think to write this out in a flow chart before you then start coding it up. So the programming language BASIC does cater to the idea of designing it first in a flow chart, and then going forward. So, have you guys ever seen the movie Social Network? So, there's a scene in the movie. This is, I mean, I kind of question this scene, but so anyway, this is a movie about the creation of Facebook. And so the guy who created Facebook, this movie goes back and forth between like a lawsuit, and then they go back to the past as the product was being made. So the scene that's coming up is 2 things that are interesting. One is the guy who created Facebook, he was going to school at Harvard University, and Bill Gates also went to Harvard University. So the guy who created Facebook and Bill Gates both went to Harvard and both dropped out because they were making a product that they didn't, if they went to school, they wouldn't be able to make the product. So they dropped out of school to obviously do something better. So there's a scene where he goes to a talk by Bill Gates. Bill Gates comes back to Harvard and he starts talking about what he did 30 years ago when he was a student. And he's talking about how he was making a basic, the programming language BASIC, a compiler that people could write basic code and write programs with. And then the scene after that, they go to his apartment where he's working on Facebook, and on the wall is a flowchart. So I'm almost, I almost question whether or not they would draw a flowchart. Facebook was built back in 2003, but they edited to the movie, so.
Doesn't matter.
So this is Bill Gates talking, a guy acting like
It was a beautiful day. I was in my wrapped up boardroom. He brought that magazine out and he showed it to me. And he said, look, it's going to happen without us. We've got to start now. And I said, okay, let's get basic out there. Now, most of you think you know the rest of the story. You may not. The beginnings of this industry were very humble. That computer on the cover of that magazine had an 8080 processor. Unless you paid extra for a 1K memory board, we got 256 bytes. So the challenge when I wrote BASIC wasn't just to run at 4K bytes, but I also had to leave room for the users to run their programs in 4K bytes.
So this would be 1974 he's talking. So what Bill Gates was talking about was when he came out with it, he didn't invent BASIC, that came out in 1964, but in around 1974, he came out with a way that people could use it on their home.
Which is only great for two reasons. One is Facebook, right? And then the other.
So then, right after this, they go to his apartment and you see a flowchart on his whiteboard.
Yeah. I'm Stuart Singer. I'm in your OS lab.
Sure.
Awesome job. Facebook.
Awesome job. Thanks. I'm Bob. You know, I could swear he was looking at you when he said the next Bill Gates could be right in this room. I doubt it. And I showed up late. I don't even know who the speaker was. It was Bill Gates. Shit, that makes sense.
All right, thanks, guys.
You were wrong, man. You see Bill Gates is looking for Alex. So at least we got covered on the doing stuff.
I get a clock. I can monetize them. What were their names? What I just said?
What?
I said it's time to monetize
This whiteboard right here, is the flowchart for the beginning
It's
of
a website to start
Facebook.
generating revenue.
They've got all the diamonds and the arrows, how it all flows together.
Advertising.
No. Well, we got 1,000 members. Because the Facebook is cool. Like, we started selling pop-ups for members. It's not going to be.
So I just wanted to show that, I mean, I kind of find it